Hey y'all, we are going to look at some scientific notation problems. Let's open this up. We are actually going to do, if it'll let me, we're actually going to do a new one. So let me go back. Let me get a new one. Okay, so I never really know where I start. It may have been perfect where it was. So scientific notation is going to actually be like an application of what we learned with our exponents. And scientific notation is going to be something we use whenever we're dealing with really, really large numbers or really, really small numbers. Okay, so mathematically you would use this in like maybe a science field, or you're dealing with like microscopically small stuff, and you don't ever really want to write so many zeros. And so what you could do is you can actually convert it into a scientific notation. So we're going to probably do a video going over scientific notation, and then we will do a video going back to standard notation. That's whenever you do write the really, really large number or the really, really small number. In this section, we will actually use that mathematical symbol for multiplication, the X, that we're taught not to use in equations, but because this is scientific notation, it is okay to use it here. Sometimes you'll see a capital E or a lowercase e, like in your calculator. So those would be the different ways you could see these represented. So, okay, the way you're going to see scientific notation is you're going to have a number, okay, and you're going to have your multiplication symbol, and then you're going to have the number 10, because these numbers are what you would call base 10, and then you're going to have an exponent. So your number has to be in between the number 1 and 10, okay? So the way you write that is our number needs to be in between 1 and 10. Now, the thing is, our number, our A, can be greater than or equal to 1, but it has to strictly be less than 10. And then our N right here, our integer must be an integer. Well, you hear how I said it? I did it again. My brain knew where I was going. My exponent, N, my exponent must be an integer. That's basically just saying that it can't be written in a fractional form, and it cannot be written as a decimal. It needs to be written as an integer. Okay, so what I'm going to do is tell you a couple of things, and then we're going to do an example showing you both, okay? I just never can quite get this to zoom out as much as I would like. Okay, let's do, basically these are like little notes. So the way we convert to scientific notation, okay? When decimal goes left, that's a keyword, exponent goes up. So literally when the decimal goes to the left, our exponent's going to go up. Okay, and then similarly, when the decimal goes, yep, you got it. When it goes right, our exponent goes, yep, it goes down. So when our decimal goes to the right, our exponent's going to go down. Okay, so I'm going to actually show you an example of both. I'm going to write it first. Y'all should have your notes in front of you, okay? So I can scooch up. Okay, so let's do an example. My example, I'm going to show you a standard notation, and then we're going to convert it into a scientific notation. So say we have the number 156,000. So that's what, 156,000? Not really that huge, but you could see examples where it's 1.5,600,000, but that's a huge number, right? So this is just to kind of show you how it works. Now, what I meant by when decimal goes to the left, the exponent goes up, I mean that it's positive. Okay, it's not going to be a negative number because it's going up, so it's getting bigger in the positive direction. The alternative of that is going to be when the exponent goes down, and what I mean by that is it's going negative. Okay, so for this example, if you have a standard notation, 156,000, and it tells you to convert it to scientific notation, well, the directions told me when my decimal moves, right? There's not a decimal on here, is there? No, but it's to be implied. It is to be understood that because this is a whole number, it's not already a decimal number. The decimal is right there at the end, right? Now, in order to do the scientific notation, it told me that I needed a number, and then I used that X for the multiplication symbol, and then I have 10 raised to an integer. So my boundaries, my stipulations, right, my rules for my number was that it was in between 1 and 10. So let's move my decimal until I get to that. This would be moving it one time to the left, right? Okay. And then if you look at 15600, is that less than 10? No. Move it again. Would that be less than 10? 1560? No. Move it again. Now I'm at 156. That's bigger than 10. Move it again. Now, to the left of my decimal, if that's where I placed it, I would have 15. Yeah, no, that's bigger than 10. Move it again. Do you agree with me if I place my decimal right there? The number that I'm looking at, which would be my A, would be 1.56. That's close to the number 2, right? Which is definitely less than 10. So I'm going to rewrite that right now, okay? I get 1.56. There's really no need to write the rest of the zeros. That's why we're doing this. I would include my 6. I wouldn't just do 1.5. You do include the numerical values that are higher than 0 in this case. And to actually write it, look, like my scientific notation, it's a number, my multiplication symbol, X to the something. So my A here is 1.56. It told me to do my multiplication symbol, 10. Ooh, I do that all the time, 10, I don't like it. 10 to the, well, how do I figure out my exponent? Look, when the decimal goes left, my decimal went left, right? The exponent goes up. And what I mean by up is it's positive. And what you write is the number of moves, the number of spaces, the number, I like moves, the number of times you moved it, right? So let's go ahead and clarify this too. Whenever I say down, what I'm saying is that it's going to be a negative value. And that value is going to be the number of moves. So let's look back at where we were. We had 15600. I moved my decimal 1, 2, 3, 4, 5 times. I also had wrote that when my decimal goes to the left, my exponent goes up. So it's a positive 5. That is how you would write 156,000 in scientific notation form. Does that make sense? Okay, so let's do an example when instead of starting with a really large number, we start with a really tiny number, really small number. say the number we're starting with is 0.1, 2, 3, 4, 5 zeros, and then 53. So I know that this is tenths, hundredths, thousandths, 10,000ths, tenths, hundredths, thousandths, 10,000ths, 100,000ths, 100. Yeah, like it's fairly small, right? I'm not even positive what place I would call the 3 without really looking at maybe some notes on the different place values, but that's a very, very, very small number. Well, when I'm doing my science work, I don't want to keep writing all of those zeros. So instead, I'm going to convert it into scientific notation. I had like a hiccup there. So this number actually already has my 0 next to a decimal. I didn't have to add a decimal like I did up here, right? So all I'm going to do is I'm just going to move it. Would I move that decimal to the left? No, because that I would just be adding more and more and more zeros, right? So in this problem, what we do is we're going to move our decimal to the right until I stop with it pretty much giving me a number between 1 and 10, right? My goal is to be greater than 1 and less than 10. So let's move it. 1, 2, 3, 4. Would I stop there? I'd be at 0.053. No, because that's still less than 1. Okay, what about stopping here? I would have 0.53. No, that's also less than 1. If we move that again, I get here. And now the number that I have is 5.3. 5.3 is almost right in the middle of 1 and 10. And I know that that's the rule, right? Like that's what I'm going for, is a number greater than 1 and less than 10. So I would put my decimal right there. Now let me go ahead and write that new number that I have. 5.3. I know I have a multiplication symbol. Now look at your notes. When the decimal goes to the right, the exponent goes down. And what I mean by that is the exponent goes negative, right? And it goes to the negative value of the number of moves that we made. So we have 10. Now let's count our moves. 1, 2, 3, 4, 5, 6 moves. So it's a -6. Is that good, y'all? That is how you convert from standard notation into scientific notation. Okay, so I'm going to come back with a how to convert to standard notation video. I'll make sure you ask me if you have any questions, okay? Bye.